Now over to the methods of solving resultant vectors. Actually, we have three methods of solving resultant vectors. Number one method is called the Pythagoras theorem. The Pythagoras theorem method. Now we have the second one called the Parallelogram. The Parallelogram method. And lastly, we have the triangular method. We have the triangular method of solving vector. But this method, the third method, should be treated under moment of a force. That is where we are going to see this method very well, where we make use of the Lamy's theorem in solving vectors. It's peculiar to moment of a force. So our focus here will be on parallelogram method and the Pythagoras theorem method of solving vectors. So first of all, let's pick the first one, the Pythagoras theorem method. Now, the Pythagoras theorem method of solving vector deals with when vectors, after drawing your questions, after drafting everything, and you find out that your diagram gives you, of course, this only works when you have two vectors. Now, when your diagram gives you a right-angled triangle, Now, if I bring out a vector always, the resultant vector always comes from the point of intersection where the forces are acting. So if I bring out this resultant vector R, if here is vector A, for instance, and this is vector B, if here is vector A, here is also vector A. This forms a right-angled triangle. So, the Pythagoras theorem, you use it to solve for the resultant when the diagram forms a right-angled triangle. So what does the Pythagoras theorem states? It states that in a right-angled triangle, that the square on the hypotenuse side, in this case our resultant is the hypotenuse side, the square on the hypotenuse side is equal to the sum of the squares on the adjacent. In this case, our adjacent is B, and the opposite. The opposite of a right-angled triangle is the side facing the direction of the resultant. So, by Pythagoras, the square on the hypotenuse side is the side facing the angle 90 degrees. R squared, the square on the hypotenuse side, is equal to sum of the squares on the opposite side, which is A, and the adjacent side, which is B, the sum of these squares. So this is what we call Pythagoras theorem. Always remember, Pythagoras theorem can only be applied when a vector question forms a right-angled triangle. So I'm going to put down the Pythagoras, stating of the Pythagoras theorem. So this is what, by putting it down, this is what the Pythagoras theorem states, that in a right-angled triangle, you cannot use Pythagoras theorem if the angle does not form a right angle. If the triangle does not form a right angle. In a right-angled triangle, the square on the hypotenuse side is equal to the sum of the squares on the opposite and the adjacent sides. So with the illustration, I've shown you what that means. Now, before we go into applying this particular method of getting our resultant question, I want to explain something very important that gets some students confused, and that is the direction of the resultant. If you understand what you're about to solve, solving it is not a problem. The problem is that most of us always cram. That is why we are here. We are here to be clarified. Please, the direction of a resultant Each time they ask you a question to get the resultant vector, you always be asked the direction of that resultant. Now, what is the direction of a resultant vector? The direction of a resultant vector is that angle. First of all, is an angle. It is that angle the resultant vector makes with the horizontal. It is the angle because anything you are getting a resultant is the magnitude. But you are calculating resultant vector is a vector. So a vector must have a magnitude and a direction. So whether they are asking you to get the direction or not, it is your job to get the direction irrespective of the question. When it is stipulated in the question that the direction must be given, you must put it down because you are solving for vector. If you only get the answer alone for resultant, that answer is just a magnitude. You have not finished the question. So you have to go and get the direction. So the direction is that particular angle the resultant vector makes with the horizontal, not the one it makes with the vertical, but the horizontal axis. So look at what I mean by that. Now we have two axes. This is the horizontal axis. This is the vertical axis. So if I draw a line, a single force that will have the same effect this way, this is called the resultant. This is the angle the resultant makes with the vertical, while this is the angle the resultant makes with the horizontal. This is our person of interest, or should I say the angle of interest here. This is our direction of this resultant, not this. Because we are going to come to complicated questions. Sometimes you will be given a direction. When we reach the resolution of vectors, you will be given a two-direction, a direction here and another direction here. Please, the direction of any vector is the angle it makes with the horizontal. Okay, with that being said, let's dive into questions. We are going to use one question to explain how to apply the Pythagoras method of solving resultant vector. We are going to use this example to explain further how to and when to apply the Pythagoras theorem method of solving resultant vector. For more questions, go to the exercises, the section for the exercise. You can click on it and then get more questions concerning this. Okay, now let's solve the question and see. The question says, a boy running in the northern direction later changed his direction. The first direction, the northern direction. So we have our four cardinal points. This is the north. This is the east. This is the south. While this is the west. So a boy running in the northern direction, which means the boy started his journey, let's say here, and is running northern direction, this way. Later changed his direction and started running towards the eastern direction. This is where the boy started his journey, running towards here. Now from here, he now changed towards the east side. This is the east. Towards the east side. From north now towards the east side. Now we have eastern direction. If the distance he covered in the northern direction, when it was going to the northern direction, is 4 kilometers. So the distance from here to this point is 4 kilometers. And in the eastern direction is 3 kilometers. That means this distance is shorter. 3 kilometers. Determine the magnitude of his resultant. So as you can see, these two vectors, after drawing, the outcome is actually inclined perpendicular. As you can see, the two vectors are inclined perpendicular, which is another way of saying at right angle to each other. So we get our resultant. Either you complete this way. This is how you can get a resultant vector. So this is what we have. Now this is the direction of the resultant vector. Now we complete this. Now this is a resultant vector. You can use this, or you can decide to clean it up and use this. Now how do you solve this? We have the resultant. We're making use of the Pythagoras theorem, which says the square on the hypotenuse. The hypotenuse is the resultant magnitude of resultant vector we are looking for, is equal to sum of the squares on the opposite, the side facing the angle is the opposite, plus the adjacent, 3 squared. So this gives us 16 plus 9. And 16 plus 9 is 25. That is our r squared. But we are not looking for r squared, we are looking for r. Therefore, r is simply the positive square root of 25, which is 5 kilometers. So once you get your diagram correct, and you find out that these vectors are inclined at a right angle or at perpendicular to each other, therefore, you make use of what? Your Pythagoras theorem. Now, question 2 says his direction. In some questions, you will not be asked his direction. No. They will simply ask you the magnitude of the resultant, but make sure after getting the magnitude, this is a vector, you must solve for the direction. Now the direction, like I say, is the angle the resultant vector makes with the horizontal. So this is the horizontal. Now we get this angle. So I'm going to solve that here. So this is, we make use of SOHCAHTOA. We make use of SOHCAHTOA. Sine, S stands for sine. This is opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. So let's say, always remember the side facing the angle in question is the opposite. So we have opposite, and we have an adjacent. So we are making use of tan. So we have tan theta is equal to the opposite, which is 4, over the adjacent, which is 3. So 4 divided by 3 will give us 1.333. Then the theta itself is tan inverse of 1.333. So that will give us 53.1 degrees. 53.1 degrees. That is the direction of this particular question. Now, sometimes here, Jamb will like to know this magnitude, where is it actually pointing towards? It depends on what you are picking it from now. This is actually a displacement, the point from here to this point. Now, this is where the journey ended. So if we draw a cardinal point here, this is where the journey ended. So the direction is coming from this point to this point. From here to this point. Now, we have gotten this to be 53.1 degrees. We have theta here to be 53.1 degrees. If from here is 53.1 degrees, now what is this particular angle? From here to this point is 90 degrees. So if you subtract 53.1 degrees away from 90 degrees, you will get 36.9 degrees. 36.9 degrees. Now, that means that this point is 36.9 degrees. If they're not asking you, Jamb, please be very careful with this. Now, the proper direction, or another way you can refer to this is by saying, remember, once you draw this, this becomes south, while here becomes your west. So this becomes the direction of this becomes south 36 degrees west. That is the direction of this resultant, south 36.9 degrees west. If it is the nearest whole number, it becomes south 37 degrees west. But if you are making use of this, now, if this direction is this, that means that here becomes 36.9 degrees. In this case, the direction of this is now north 36.9 degrees east. So it depends on what you are using as your direction place. But in this case, this is more accurate than this, because this is where the final movement of the ball stops, not here. And the displacement is the point from the final destination to the starting point. That is what you call the direction goes with the horizontal, not the vertical. Okay, if you go over to the exercise section, you are going to see more questions on this. Please be very careful with this. Any question, drop in the comment section below. We explain more on that. Okay, let's move over to the next method, which is the parallelogram method of solving that. Please be very careful in this section. It is not as easy as the Pythagoras theorem method. This is a little bit trickier than the Pythagoras method. So we go over to the parallelogram method.